Good afternoon, everyone. Today we will explain Newton's method, okay? Section 4.8. So, let's start. We will explain Newton's method from this file. For this section, you need your calculator. Let's prepare the calculator. But before starting, oh no, it's written here. Newton's method is a method to approximate solutions for equations, okay? Because you don't always have formulas, right? For example, you have formula for the equation ax squared plus bx plus c equals 0. We have formula for this, right? The formula is x equals, if I want to find the solutions of this, I have formula, right? Minus b plus or minus square root of b squared minus 4ac over 2a, right? So this equation is easy, we can solve it, just substitute the numbers, right? What about if you have for example e to x equals x squared plus 1? Do we have equation, I mean formula for this? What do you think? Is there formula for these equations, e to x equals x squared plus 1? Do you hear me?
Yes.
What do you think? Is there equation for such equation?
I think we can use Linux.
No, there is no formula for this, right? There is no formula. But you can solve such equation using graphing, for example, or using Newton's method. For example, you can use the graph. Let's see this much. For example, e to x minus x squared. No, not like this. Graph e to x, then x squared plus 1. So here, see, you can solve equation using the graph. For example, you have solution 0, 1, right? I mean x equals 0. You don't have another solution. So sometimes you can solve equations using the graph. Sometimes, let me show you another example of equation that you cannot solve using formula. You don't have formula for it. For example, if I give you x equals cosine x. Again, same idea. We don't have formula for this. You can solve it by graphing or using Newton's method, right? Now let me ask you again about polynomials. This here, quadratic, we have quadratic formula. Degree 2. These are degree 2 polynomials. We have formula. What about degree 3? Do we have formula? I will show you. We have formula. See this one. For quadratic, you have this formula. For cubic, you have this formula. Would you like to use this to solve a cubic? What do you think?
No.
It's very complicated, right? It's not just complicated, it's also not useful. Sometimes, for example, sometimes you may have solution x equals 1, but it has a very complicated shape. I mean here, when you substitute, you have cube root, square roots. Sometimes it's not clear what's the result, even if you use this formula. So it's complicated and useless. So you don't have good formula for cubics. Do you think is there formula for degree 4? Yes, there is formula for degree 4. See here. This is polynomial of degree 4. Here is the formula. So the first solution is this one. Okay? See? It's very complicated, right? Would you like to use such formula? Clearly no, right? So you have formula for degree 3, for degree 4, but they are very complicated, right? So what about degree 5? For degree 5, fortunately, we don't have formula for degree 5. Even if we have, it will be something useless. But we don't have. I mean, they proved that we don't have formula for degree 5. We have for degree 2, for degree 3, for degree 4, but degree 5 and higher we don't have. So in general, how to solve these equations easily? How to solve them easily without using this very complicated formula or this? We use Newton's method, right? So the nice thing about calculus, it gives us a lot of useful tools. For example, one of them, Newton's method. You use easy calculus to find solutions of very complicated equations. Let's start now explaining the Newton's method. But here, don't study this cubic formula or fourth degree formula. I think you want to tell me, even if you tell us to study them, we will not study them, right? Let's continue. Now, here is the idea. The geometry behind the Newton's method is shown in figure 2. I will show you. See the graph. The solution of this equation is r, right? Because we are solving equations. Let me show you the idea. We are trying to solve equations of the form f of x equals 0, right? So our solutions lie on the x-axis. So here r is the solution we want, r. Are you good with this? Now what's the idea of the Newton's method? That you choose point x1, okay? You find the tangent line. The tangent line crosses the graph here. I mean the x-axis here, right? But it's still not close to r, right? But not here. That first we choose x1, right? So see here again. We start with x1. See x1. This is the distance between x1 and r. In red, the distance between x2 and r. x2 is the second point. I mean the intersection of the tangent line with the x-axis. Which point is closer to, which x value is closer to r? What do you think?
x2.
x2, right? So
Yeah.
so the idea here that when you use the tangent line of the x1, you get closer to the solution r, right? Now if you use it again to x2, find the tangent line for x2. See here, you get here x3. Is it closer? Yes.
Yeah, it is.
So again, use the same idea. You will get very close to the solution. So this method is very easy, right? This is the graph explanation. But now I will show you the formula, how to find it. The formula is easy. You will find the tangent line. I will show you now. So let's see here again. So the geometry behind the Newton's method is shown in figure 2. We explained this. We wish to solve an equation of the form f of x equals 0. So the solutions of the equation correspond to the x-intercepts of the graph of f. X intercepts the intersection with the x-axis, okay, as I told you. The solution that we are trying to find is labeled R in the figure. See here, it's R. We start with a first approximation x1. I will explain how to start with the first approximation x1. But first, let's understand the formula and the idea, which is obtained by guessing. Here is the idea, by guessing. I will tell you how to guess the x1. Sometimes x1 is given. Sometimes you need to think how to find it, but it's easy to how to find it. I will tell you. Or from a rough sketch of the graph of f, or from a computer-generated graph of f. Consider the tangent line L to the curve. I think we explained this. I need to, yes, here. We are at this part, to find a formula for x2. Let's see the graph again. What's the formula of the tangent line for x1? What do you think? Y minus fx1 equals f prime of x1 x minus x1, right? Are you good with this? Good.
Yes.
How to find the value of x2? What's the point x2? x2 is x2. The x value is x2. The y value is 0, right? Substitute x2 0 here. You get y is 0 minus fx1 equals f prime x1 x2 minus x1, right? Divide both sides by f prime x1. You get minus fx1 over f prime x1 equals x2 minus x1. Add x1 to both sides. You get x2 equals x1 minus fx1 over f prime x1. Do you understand the formula? Are you good with this?
What, Professor?
What?
What did you say? I didn't hear you, Professor.
You didn't see the screen?
What?
What's your question?
Should I type my name or no? Because I've been here before the class started.
Ah, yes, you need
I forgot to type my name, but I've been here before you even came.
yes, but you yes, write your name and student ID here in the chat.
Okay, ترتيب.
Yeah. Now let me ask you again. Is the formula clear for x2? This is important, so you need to tell me. You need to ask me if it's not clear. Is it good?
Professor, it is clear, but I don't understand, like, what is happening there?
Again, let me show you. Again, tell me. The idea, again, as I told you, we want to approximate the value of r, right?
Yes.
So each tangent line intersects the x-axis and gets closer. The point of intersection gets closer to r, right?
Yeah.
So this x2, you need to find it, right? How to find it? You substitute it in the line, in the tangent line. Then when you solve for x2, you get the value. You get x1 minus fx1 over f prime x1, right?
Okay, yes.
So this is how to find x2. But now, what should we say here? I divided by f prime x1, right? So what should I say here about f prime x1? When you divide by something, you need to say what? That this is not 0, right? So f prime x1 is not allowed to be 0, right?
Yes, it is the ordinary.
Now, same steps, if you draw the tangent line of x2, I mean, you make the formula of the tangent line of x2, and you substitute x3 0, you will get x3 equals x2 minus f of x2 over f prime x2, right? Do you see the pattern here? Here x3 equals x2 minus f x2 over f prime x2. Then x4 equals x3 minus f x3 over f prime x3. In general, what do you have? xn plus 1 equals xn minus f of xn over f prime xn, right?
Yes.
So, but in all of these, you need the derivative to be non-zero, okay?
Okay.
Let's get back here. I will give you example, so it will be clear after a little bit. Now, see here the graph of the, when you draw more than one tangent, you keep getting closer to the R, right? See here, x1, then x2, then x3, then x4. So if we keep repeating this process, we obtain a sequence of approximations x1, x2, x3, x4, etc. as shown in figure 3. In general, if the nth approximation is xn and f prime xn is not 0, then this is the formula. So you need to remember this formula, okay? This formula is very much important. Now as n goes to infinity, you get the exact result, the exact value as n goes to infinity. But here there is something important. Although the sequence of successive approximations converge to the desired solution for functions of the type illustrated in figure 3. So in figure 3, for this function, the sequence converges to R, right? Goes to R. But see here the warning here. In certain circumstances, the sequence may not converge. For example, consider the situation shown in figure 4. See figure 4 here. For example, I want to approximate R, right? You choose x1, you draw the tangent line, you get x2. Then draw the tangent line for x2, you get x3. But see, x3 is not good, right? Right? What do you think? Is x3 closer to R than x2?
No.
So the idea here that some functions the method is not good, but it's not good because you need to choose the value close enough to the value of R. But now you will tell me how to know how close it's to R if I don't know the value of R, right? You may ask me this. I will tell you how to do it. So see here, the Newton's method fails, and a better initial approximation x1 should be chosen. Let's solve this problem here. Here we have example. I will tell you how to do it. So see here this example. We want to solve x cubed minus 2x minus 5 equals 0, okay? We have the value of x1. x1 equals 2. Now see here how to solve. You need to solve as I'm writing now, okay? So you write first the formula, okay? This is the first step. You always write the formula. xn plus 1 equals xn minus f of xn over f prime xn. Good?
Yes.
So now you substitute in the formula to get x2 and x3. Here the example tells you find x3, right? So how to find x3? You substitute 1 here. You get x2 equals x1 minus f of x1 over f prime x1. This equals what? Equals x1 minus, what is f x1? You substitute in the function x cubed minus 2x minus 5, right? You get
Yes.
x1 cubed minus 2x1 minus 5 over, you find the derivative now. What's the derivative of this?
3x squared
Yes?
x squared
Yes, thank
minus
you.
4.
Now you substitute x1 in the derivative, you get 3x1 squared minus 2. Good?
Yes.
So now you use your calculator to solve this. What is the value of x1? 2, right? Substitute
2.
here. You get 2 minus, then open parentheses for the division, okay? Parenthesis 1, then second one for the upper part of the fraction. You get 2 cubed minus 2 times 2 minus 5. Now close the parentheses for the numerator, okay? Now divide by, now we are substituting in the derivative, okay? 3 times 2 squared minus 2, then close the two parentheses, okay? You get what? 2.1. Are you good with this? Good? Do you understand how to do it?
Yes. We just substitute the values.
Okay. Now, in your calculator, you can use the button answer for this, right? So here write 2.1. For x2, write 2.1. Then go to x3. For x3, no need to keep writing again and again the same formula. See here, you write it once, then you substitute in it, okay? So let's see now. For x3, I will write it just on the calculator. No need to. So Control C. I will use Control C here. So see here, Control. Now let's start. So we have x2 minus. Now again. Now substitute 2.1 in the original function, x cubed minus 2x minus 5. So we get Control V cubed minus 2 times 2.1 minus 5, then close it, close the parentheses, divide by the denominator. Now you substitute in the derivative, you get 3 times 2.1 squared minus 2. Now you close the parentheses, okay? You get what? 2.526. Now here important thing, you write for example 6 digits of this, 6 digits to the right of the decimal point, okay? 6 or 7 or 8. I mean, don't write just 1 5, for example. Write some of them, 6 or 7 digits. Let's write 6 digits, okay? And don't approximate. So here, see. For example, if you have 9, don't approximate and write 7. Write it 6. Keep it as it's in the calculator, okay? Are you good with this? Do you have questions? Do you hear me?
Yes.
Okay. Rahel Adel. Rahel, right?
Yes, Professor.
Yes. Hamza Hassan.
Yes, Professor.
Okay. Now we'll solve another example. But let's check our solution from here. I think the second step is not correct in my solution. Let's do the second step. Let's see.
Yes.
What's
The
the,
answer wasn't correct.
what's the problem with the second step? Yes. At the end, I didn't write 2.1. I wrote 2.
Yes.
I will do it again. So here we have again 2.1 minus, you open two parentheses, one big parenthesis, and the inside, the inner one for the upper part of the fraction. Okay, so 2.1 cubed minus 2 times 2.1 minus 5, then close the parentheses for the numerator, then divide by the denominator, open parentheses for the denominator, you get 3 times 2.1 squared minus 2, then close two parentheses. Now it's correct, right?
Yes. 2.09.
Now this, it turns out that this third approximation x3, that is nearly 2.0946, is accurate to 4 decimal places. Here you know that it's accurate for 4 decimal places by calculating the exact value. But here, the next example, there is something important that I need to explain to you. See here, this one, example 2. Let's solve example 2, and example 2 is very much important because I will explain to you how to find, for example, if you don't have the function, how to find it and how to find x1. Okay. So see here, use the Newton's method to find 6th root of 2 correct to 8 decimal places. This example is very much important. We need to explain the idea how to find the function and how to know whether your solution is close to 8 decimal places or not. Okay. First, look at here. You write x equals 6th root of 2. Okay. You start with this step, 6th root of 2. Then raise both sides to 6th power. Okay. You get x to 6 equals 2, right? Then subtract 2 both sides, you get x to 6 minus 2 equals 0. Do you have the function now? Right? What is the function here? F of x equals what?
X to power 6 minus 5.
Yes. So x to 6 minus 2. Please, if you have any questions, you can ask me because this is very much important. So f of x equals x to 6 minus 2. Next, let's find the derivative. F prime of x equals what?
6x
To 5, right?
Yes.
Now, let's also write the formula. Xn plus 1 equals xn minus f of xn over f prime xn. This equals what? Xn minus, you substitute xn in f of x, you get xn power 6 minus 2 over 6xn power 5. So you write the formula once like this, and then you no need to keep writing it again. Just write it once, and then you use your calculator to find the values. But now let's explain the important idea about how to find x1. Remember, I told you that your initial guess is x1, right? You need it to be close to the solution. You need it to be close to 6th root of 2. Now you want to ask me, how can we choose it close to the solution if we don't know the value of the solution, right? You may ask this. But
Yeah.
it's good. I mean, it's easy. I will tell you how to do it. What is 1 power 6?
1.
1, right? What is 2 power 6? 64. So, which x value is closer to 2? 1 to 6 or 2 to 6?
1 to 6.
So, x1 equals 1 is good, right?
Yes.
Even if you want, you can take x1 equals 1.1. But 1 is easier, right? Let's take it 1. But the idea, you can find the x1 similar way to this. What did we use here? The intermediate value theorem, right? You know that x to 6 minus 2 is continuous, right?
Yes.
So we know that x to 6 minus 2 satisfy any value Oh, no, not x to 6 minus 2. I mean x to 6. Because here, see, I calculated 1 to 6, 2 to 6. So I'm talking about x to 6 without the minus 2. Okay? So x to 6 will satisfy any value between 1 and 64, right? And one of these values is 2, right?
Yes.
So this is the idea. Let's start with x1 equals 1 now. And then we start applying the formula. So x1, there is still another important idea that we need to explain. How to know the solution, whether it's close to 8 decimal places or not, okay? While solving now, I will tell you. So x2 equals, let's use the calculator now. So you have 1. Look here, you substitute here, okay? In xn minus this. So you have 1 minus, you open 2 parentheses, then 1 to 6 is 1, right? Minus 2, you close the parentheses, then you divide by 6, right? You get what? 1.1,
6.
you get like this, 1.16 repeating. Now let's go to x3. See here, they both have 1, right?
Yes.
So we know that one is correct for both of them. Because you know that each approximation gets closer, right? So here, if this is 2, then we know that this one is not correct. But now, since it's 1 in both of these approximations, we know that this one is correct, right?
Yes.
Now let's go to x3. Now here, for this one, you use the button answer on your calculator. Because here you have a lot of 6's, right? You cannot write it. So you use this, you substitute it in the formula. So you write answer minus answer power 6 minus 2 over 6 times answer power 5. You will do this. But here on my computer, I will use the Control C and Control V, okay? So here, Control C. Let's start again. We start with x2 minus, you open the 2 parentheses, then x2 power 6 minus 2, then you close the parentheses, divided by 6 times power 5. You get this, 1.126 So 1.126 again 44367. Let's keep writing 8 digits to the right, okay? Because the question asks us to find it accurate to 8 decimal places, okay? So here you need to write 8 to the right of the decimal point. Good? Are you good with this?
Yes.
Now see here, look at x2 and x3. I will use another color. For example, let's use this one. Here you have 1.1, here you have 1.1. They are the same, right? So you know what? That this one is correct, right?
Yes.
But 6 is not correct because here it's 2. This 2, we still don't know whether it's correct or not. We need to find x4. If in x4 it's also 2, then we know it's correct. Now I will find x4. Let's go to x4 now. You keep finding more values until you have 8 decimal places, okay? But if you want, before that, let's continue. So Control C this value again, which is x3. Then Control V minus, you open 2 parentheses, then power 6 minus 2, you close it, then divided by, open another one for the denominator, 6 times Control V power 5, you close the 2 parentheses. You get 1, 1, yes. It's correct like this, right? Yes. So now what are the correct decimal places? To the right of the decimal point. See? 1 2
Yes.
1 2, right? So we have
Yeah.
true to up to 2 decimal places. But don't worry. I think we in this problem we will need up to x6. I know this because I solved this problem before. So let's continue now. Let's go to x5 now. So x5 equals, now control C again, control V minus, so control V minus, now open two parentheses, power 6 minus 2, close it, then divide, open parentheses, 6 times control V power 5, then close two parentheses. You get this.
So,
Now it's a true up to what? 4, right? 4 digits. See? Good? See, because they are the same uh, in two approximations, x4 and x5, 1 2 2 4, 1 2 2 4, right? Now x6.
yes.
Now control C again, then control V minus, open parentheses, let's open two ones, then now power 6 minus 2. You need to practice this on your calculator, okay? Now minus 2, then divide by 6 times control V power 5, close two parentheses. Yes, good. Now it's correct up to what? 7 places, right? Are you good with this? Now let's find x7. So control V minus two parentheses. Now power 6 minus 2, you close it, then you divide, open parentheses, 6 times control V power 5. Close two parentheses now. Now you have it, right? So 1.1224620 Do we have 8 decimal places now? What do you think? Is it clear? Do you hear me?
Yes, Professor, it is so we have the egg decimal.
Yes, Professor, we can hear you.
Okay. Now let's use the calculator to find the value to see whether our solution is correct or not. So 2 power 1 over 6, right? Because the sixth root is 1 over 6. Power 1 over 6. It's correct, right? 1.1224620 So we have it correct to 8 decimal places. So this section you need to practice. It's very easy, right? You just substitute in your calculator and you write the results. You write the formula for once at the start, xn plus 1 equals xn minus fxn over f prime xn. Then you substitute fxn and f prime xn, you get this. Then you find the values. You need to solve like this. Now let's go to the file again.
Yeah, it is
I think here he might have approximated
yes.
it for 5, right? When
Yes.
I calculated it, it was 4. So I think he approximated it to 5.
You just rounded up.
But I think it's better to find x7 to make sure that I think he counts the 1 also among them, right? Because see here,
No, he didn't count it. The same. Eight decimal number of them. One,
let's see,
1 point.
let's see again our solution. But it must be 4, not 5. But I think he approximated it to 5, right? Because it's 8 before it.
Yes. I think he did it.
Yes. So he wanted it to be 5. I mean by approximating the it to be here 5. Okay. Now let's see. Now this example here is very much important. The cosine x equals x. See this one, cosine x equals x. This one is hard, right? Because we don't have formula for it. But we can solve it easily by Newton's method, right? But before that, I want to tell you how to find the x1 value. The book gives you this method here. See here, you draw the graph of x and cosine x, then you approximate the value. See here, what's the value? Here, see, it's in black. What would be your x1? You need it to be close to the solution. You want x equals cosine x, so it's the intersection, right? But what's the x value close to it? What do you think? You can take 1, right? For example. Or you can take 0.8 or 0.6 or 0.7, right? Are you good with this? Here he will take what value? I think he took x1 equals 1. But as I told you, you can choose another value than 1. You can decide. The idea that you need it to be close to the solution. But he chose 1 because 1 is easy, right? It's easier than 0.7 or 0.6. Good? So sometimes it's good to draw the graph. But I also have another method to approximate the value. Where is that? No, it's not written here. I will also show you my method to find x1, because you may don't like, especially that you don't like to draw the graphs, right? If you don't want to draw the graph, there is also easy method. I will tell you now, without drawing the graph, how to find x1. So let's start. So we have what? First you write it something equals 0, okay? So x minus cosine x equals 0. The solution of this is the same as cosine x equals x, right? So our function is f of x equals x minus cosine x. What's the derivative of this? 1 plus sine x, right?
Yes.
Now you substitute in the formula, you get xn plus 1 equals xn. You write the formula first like this, fxn over f prime xn. So f prime xn equals xn minus cosine xn over 1 plus sine xn. What's the next step? I told you that we want to find x1 another method other than using the graph, because you may not like drawing the graph, right? Then how to do it? Do you remember the intermediate value theorem? I told you about the intermediate value theorem before in this lecture, that
Yes.
if f is continuous on a closed interval ab, okay, and f of x greater than or equal to the minimum over ab, so minimum f of x over ab less than or equal to maximum f of x over ab, No, here I want not f of x, n. Okay, if n greater than equal to minimum, less than equal to maximum for continuous function, then we know that there is solution, right? If c equals n, where c is in the open interval, right? Do you understand this? Now we will use this to approximate x1. I will show you how to do it. So let's erase this. So now our function is x minus cosine x. I want the solution to be 0, right? So I want to find value, x value that equals negative value, and f of something that equals positive. So between these, our solution that we want, 0, right? If you substitute 0, what do you get? You get 0 minus cosine 0, which is 0 minus 1, minus 1, right? If you substitute 1, f of 1, we need the calculator, right?
Yeah.
If you don't want to use your calculator, substitute by over 2, for example. Substitute by over 2. You get by over 2 minus cosine by over 2 equals, cosine by over 2 is 0, so equals by over 2. By over 2 is nearly 1.57. Okay? So you know that x1 is, it's good to choose x1 between 0 and 1.57, right? If you are not sure whether this is good, between 0 and 1.57, it's
0.5.
You may want to choose 0.5, right?
Yeah.
If you are not sure, calculate f 0.5 if you want to make it better, or f of 1 if you want. Let's calculate f of 1, for example, using calculator now, because we need calculator for it. 1 minus cosine 1. But be careful here, you need to put your calculator in radians, like this, radians, okay? Now you calculate 1
Give it a
minus
second.
0.5.
Where is cosine here? Yes, trigonometry.
So 0.5, yeah.
No.
No.
Yeah, 0.45, right?
Yes.
It's positive, right?
It's possible.
So we know that our solution is between 0 and 1. Now it's better, right? Before it was between 1.57. So now it's easier to choose something between 0 and 1. You can choose 1 itself if you want. Okay? Let's choose 1 to solve as the book, okay? Now, you understand how to choose x1? Do you understand it?
It is complicated. It's hard to understand.
We don't have more time, right?
Yeah, we are definitely.
We will,
That's right.
we will continue this example next time, okay?
Okay.
We will explain it again from the start, because it's better. You need to understand all of this again, because you will forget until the next lecture. You can leave if you want. I will take the names now.
Okay. Thank you, Professor.
You are
Nice
welcome.
Thank you, Professor.
You are welcome.
يعطيك العافية يا بروفيسور.
الله يعافيك.